Hi, everyone. Thank you for tuning in to our Data 608 final presentation. Our team was Group 4, comprised of myself, Sneha, Yang, and Lou. And today we have the pleasure to share with you our Amazon product analysis. To kick things off, I just want to start with a bit of an overview of the different steps that were involved in our Amazon product analysis. So for this project, we looked at just Amazon headphones to start with. And ultimately, the goal of this project was for all the different headphones to be able to pull all of that information, all of the reviews, the pricing, the ratings of each of these products, and then ultimately put that into a dash for a user to be able to see all this information readily and be able to look through different products and see all the different information, as well as to get some insight into what some of the reviews mean and the ratings mean and how they're related. So the first step in this whole process was to develop a web scraper, which first pulled all the links for each of the products that we want to look at, and then subsequently went and pulled every review for all the products. The second step in this process was to perform sentiment analysis on all the reviews. And with that sentiment analysis, there was also a component which will be touched on by Sneha, where the reviews will be summarized. That way, the user doesn't have to read through the 1,000 different reviews for a product, but there'll just be a summary given for all of them. The next step in the project was to store all of our information in the cloud using AWS, and then finally to deploy our analysis onto a Dash application so that there's some interactability for users and they can actually see all the information that we pulled. So for the first part of web scraping, which was the component of actually pulling all the different links for each of the different products, we built a scraper utilizing Beautiful Soup. So for the first pass, using this web scraper, we just pulled a set of links. And then once we had these links, we had to modify each of them so that when they were accessed, they would direct our scraper directly to the site for that review for that given product. So we had a list of links now, and when we were iterating through, they had to go directly to the review page for that product. And then from this point, we did our first pass of generating a bunch of reviews with this original list of links. The first process here was a little bit slow and tedious, but each of our group members split the load of links together. And then through using all of our computers simultaneously, we were able to pull a decent amount of reviews for that first pass. And then ultimately what ended up happening is we did a couple more iterations, a few more passes, and we pulled multiple more links to generate our final data set, which was comprised of about 200,000 different reviews for about 200 or so different products.
After pull links for each product, we also need to pull the reviews for all the products. So we try two different ways. The first is the sequential processing, which is basically going through each page for the product one at a time. This is a slow process. As you can see on the left video here, it's probably one page for 1 second. This makes the project impossible to finish if we are going to through this speed. And that is the reason why we use the multiprocessing to pull all the reviews. Instead of going through one page at a time, it is going through 10 pages at a time, which significantly reduces the time required to pull in total 200,000 reviews altogether. This part is the sentiment analysis using Naive Bayes. Naive Bayes is a robust machine learning models to do the text analysis because it is considering the existing probabilities for the word count. And we build a pipelines for this. First, we segment the text, the sentence into words, punctuations, and also after that, we remove the noise such as the stop words, link, and also punctuations as well. And then we label the reviews based on the existing ratings. Anything 4 and above is considered as positive. Anything 3 and below is considered as negative. And then we split the data into training and testing. The training part is fed into the Naive Bayes classifier. After the model is trained, we test that in the testing dataset. And eventually, the accuracy is about 78%, which is actually decent good. One thing I want to point out that this model is using some formative features like disappointing, terrible, broke to distinguish between positive and negative.
I chose to perform sentiment analysis using multinomial naive Bayes as well as MLP. MLP is a little bit more robust. It can capture a lot of the nonlinear relationships between the inputs and the output targets, and it's also really good for larger data sets. When first trying to perform sentiment analysis, we are looking at the given rating for the products. That's 1 through 5 score. And ultimately, what I was seeing, at least in my models, was that there wasn't a lot of differential between, say, ratings 4 and 5 and what the text was actually saying, or ratings 1 and 2 and what the text was actually saying. So it was fairly difficult using those ratings to try and get high accuracies. So instead, we simplified the ratings to just be poor, comprised of 1 and 2, neutral being 3, and then good being ratings 4 and 5, and then trying to use these models again. And ultimately, we're able to achieve much higher accuracies, 86% for the MLP and 83% for the multinomial naive Bayes. One of the things that is important to take into consideration here, not just the accuracies, is the time required for training. Multinomial naive Bayes was only a few seconds, whereas MLP was closer to the 30-minute to hour range mark. So definitely something to consider in the future when looking at different models for sentiment analysis.
In addition to the above models, we have used a couple of other different approaches as well for sentiment analysis over the product reviews and rating. Since the text data cannot be passed to a machine learning model directly, we need to convert the text into a numerical representation, vectors, that is called word embedding. I use two methods, TF-IDF and word2vec. TF-IDF is known as term frequency, inverse document frequency, that counts the most frequent words and measures how often they appear in the document, thereby providing the overall weightage of a word. The other one I applied is word-to-vec embedding, which also maps the word to its numerical form. The interesting thing about word-to-vec is that it's a two-layered neural network model, which puts the words of similar context closer to each other in a vector space by capturing the semantics and context of a particular word. I used a 1.5 GP Google News 300 pre-trained model containing 3 billion words and phrases. Therefore, I implemented two models. The first one is SVC, linear, trying to fit a plane for classification of reviews. It is trained over all the given reviews and labeled ratings for both TF-IDF and word2vec. SVC with word2vec gives an accuracy of about 58%, which is less than the expected one, while for TF-IDF it comes out to be 89% approximately, which is great. The second model implemented is multinomial naive Bayes, which is based on Bayes' theorem. This model considers a feature vector where a given term represents the frequency of it, the number of times it appears. It is trained over the feature vectors of reviews and the label ratings, providing the accuracy of 58% for word2vec, which is similar to the one given by SVC, and 75% for TF-IDF. Hence, TF-IDF performs better for SVC overall than the combined four models. We've also plotted word clouds for positive and negative reviews to provide an overall picture of frequency of words. For example, the positive reviews have words such as quality, good, sound, whereas the negative reviews have words such as die, use, work, kind of similar. As we know that an Amazon product contains over 3,000 reviews for a single item of a product, and the purpose of a review summarization is to provide a brief summary of all the reviews for the customers. There are two types of summarization methods, that is extractive, where it identifies important sentences, and abstractive, where it interprets the context for a summary. We are using abstractive method, which assumes higher frequency words to be more significant. This method uses a library spaCy for tokenization, looks at the frequency of specific words, and then ranks the sentences based on the sum of frequency of each sentence. spaCy is a pre-trained NLP pipeline that interprets the grammar of the text, filters out the stop words, punctuation, and normalizes the count and extracts the higher ranked sentences, resulting in a summary of top 5 sentences.
In this section, I will talk about the AWS, about how we use cloud services in our project. So basically, we follow our plan in our project proposal. We created two tables in AWS, product table and review table. Also, we use code commit as our Git repository. So now in our database, we have 200 rows of products and 200,000 rows of reviews. We follow the agile development methodology. We separate the job to each team member and we update our progress every day. Right now, in our Git repository, we store our Dash web application. This Dash web application is to display the result of analysis and why we are using Dash, and a little bit more about Dash. So Dash is an open source framework for building data visualization interfaces. It released in 2017. And the main reason is it doesn't require you to have advanced web development knowledge to build data analytical web applications, which means it's very simple to use. It doesn't require you to have many web development knowledge. And one of the library we are using is the Dash Bootstrap Components library. So this is about Dash. Now let's take a look at our web. Okay, so this is our web. As you can see, on the left-hand side, there's a list of product names. So this is the 200 product, from our database. And once you click one, as you can see, this section is the price frequency histogram section. It will display the price frequency histogram. And also, once you click on the product, it will show you which price range it belongs to. So if right now this product price is $88, so it belongs to this section. And you just click the first one, it's $13, it belongs to this one. And also you can see the range $0 to $25 has the most items. And on the right hand side, this is the product details. And if you click on different products, it display different product details. It display the product names, review summaries, price, and number of ratings. And also down here is our trained model. So if you type in something, if you type in this is a bad product, click submit, it will display how good this review is. As you can see, right now it says this is negative, negative, positive, good, poor. This is the result of this review. And down this section, the last section is the model accuracy, the model score. And so this is about our Dash web application and AWS. Now my team member will talk about the how to deploy our Dash web application. Thank you.
After we put everything together, we also want to publish this to the AWS cloud so the public can interact with our apps as well. So we did this in 3 different steps. The first one is the Dash. We have to isolate the running environment and create our own environment text. So that includes all the packages and the dependency to run this app. And after that, we will create our own image. So first thing is to create the Docker file, which has information for the programming language that we have used for the package and dependency that we have used for the app. And then this image will be pushed to the AWS cloud, and the app will be run through the ECS task. To make a conclusion for this project, we have 4 major sections. The first is the web scraping. After that is done, we did a sentiment analysis on the reviews and the ratings. And the data is stored in the AWS database. And then we also put everything together in a Dash web application and deploy that into the cloud. One thing I want to reiterate that although we have 4 different sections, but this is really a collective project from all of us. Each of us make a significant contribution for every aspect of this project to make the product up and running. So that is everything for this project. Thank you for listening.